Hi everyone, my name is Slava, and we will not talk about wireless. We will talk about access assurance or cloud NAC. So as we are expanding our footprint and we're growing exponentially, we're growing dramatically. We are adding more and more functionalities that would cover some of the use cases that come from our customers. And today we will talk about three things. And the first thing we will talk about is client onboarding. This is something we've actually announced on the previous MFD last year. And I just wanted to go deeper into it as we're closing on this and as we are releasing the functionality. So client onboarding for us is really about how do you move a client that's unmanaged to an enterprise network on WPA3 or WPA2 enterprise. How do you push a cert? How do you install a Wi-Fi profile or wired profile easily and seamlessly as possible? Now, before we go into a demo and a deep discussion, you've heard the Marvis client mentioned a couple of times today, and you will hear about it more and more. I wanted to kind of give a brief overview of different Marvis client personas. Right? So this is where one of the persona that we will cover right now is the NAC onboarding tool. So Marvis client could just have different faces. One of its faces is actually the onboarding one, where it will provision the end user device with a certificate, with a Wi-Fi wired profile connected to the network, and then optionally, on top of that, you can then enable to send telemetry. So you can actually get client-level visibility of the network, streaming to the Mist cloud, and then providing the admin of the Mist dashboard of deeper visibility into how the client sees the network. And then the other use cases we've seen in warehouses specifically is the locationing aspect that's enabled on the Marvis client just to track the handheld scanners in those areas. But right now we are focusing on the NAC onboarding, and we will actually start with the demo. And the demo, we will start by looking at the admin side of things. So we will look at how an admin would actually start and create the onboarding process for the end users. And many of you are familiar with our PSK portal concept, where an end user, say a student, can come to the portal, authenticate through the SSO, grab their personal appreciated key, connect their devices. So that process existed for a long time. Now we are expanding that concept into a NAC onboarding portal, where the similar workflow will work for an end user to do the SSO login, and then they'll be able to provision their device with a certificate and Wi-Fi wire profile. Now, we'll look at the portal config here. So first, we'll create a portal. That portal has all the customization options that allow you to kind of get your own branding, colors, and backgrounds. The most important thing is that portal will be attached to your single sign-on using SAML. So any identity provider that you work with, whether it's Entra ID, Okta, or Google, or literally anything in the world, we will work with this. Once the SSO process is complete, the important part is the onboarding parameters. And this is where you define if a user goes through this portal and they're successfully authenticated and authorized, what do we do with the onboarding process? How do we treat them? So you're going to specify which SSID they will eventually connect to. So that can be a portal for your, say, eduroam users in a higher ed, or that could be a portal for a personal employee network in an enterprise. You can then say, do you want to also enable wired connection with .1x and certificate authentication? Do you want to send Marvis telemetry back to the Mist cloud? This way, you can actually get that client-level visibility. So that's the optional part that you can enable as part of that onboarding process. Plus, few other things where you could actually say for how long the certificate that we will issue will be valid for the end user, for the roles, etc. So now this is the admin side, right? So what's happening on the end user side is
go to the next slide. On the end user side, so first we're going to look at the mobile device. This is Android, but the process is similar for iOS as well. What I did here was I just encoded the NAC portal URL as a QR code, so you could just scan it with a camera. It will then redirect you to the onboarding portal. That onboarding portal will actually redirect you to your SSO provider. In this case, this is Entra ID. Again, can be anything else. You log in. If you have MFA will be completed at this step. Once you've logged in, you will be redirected back to our onboarding portal. It will say, oh, hey, you're running Android. If you don't have an app, go click here and install. If you do, click on the link. And click on the link. The app will pop up. It will ask you to install the network profile. Wait. It will give you one more prompt. You'll hit save. At this point, you're connected. You're good to go. Now, what's important here is this part, right? Where based on your SSO login, we will grab your identity. We will issue a certificate for that end user device using the identity from the SSO, right? So we can embed all of that information in the cert. And then the client will go through our general access assurance authentication process. You can set up your policies, look at extra checks like group memberships, things like that. But this is the end user facing onboarding process. Okay, that's mobile device. Now, the next part is what's going to happen on a desktop, whether it's Windows or Mac OS. Again, very similar. We will look at the SSO login first. Once you've logged in, it will detect that you're running Windows. It will ask you to open the app if you already have it. It will then go through the enrollment process. And as you can see in the bottom right corner of the screen, the client is already trying to authenticate to that network as it's installing the Wi-Fi profile, and it's now on that destination SSID at this point. Right. So that onboarding process is very very simple for the end user to follow. And let me actually stop the video playing. Okay. And whether you're on a mobile device, whether you're on a desktop, that's your typical BYOD flow. And the primary use case, obviously, for that is higher ed, as students bring in all sorts of things, and you want them to be on eduroam network, or you want them to be enabled for WPA3, et cetera, et cetera.
Yeah, just curious, are you seeing uptick in 2FA requirements for the onboarding process?
So the onboarding process is something you will complete probably once. Again, let's talk about, let's say, higher ed. You'll probably do it once a year or once a semester, depending on the policy requirements of the university. Or some customers would actually say, well, hey, issue is certificate for 5 years. I don't care. I'm going to check if the user is valid. The MFA is there usually enabled by default, because all the IDPs today would enforce you to have MFA enabled when you're going through this kind of web type of authentication process. But once you've done that onboarding, the way you connect to the network is you're presenting your cert, right? So that's completely transparent to the end user. That Wi-Fi profile gets embedded in your machine. You have a cert. That cert identifies you, and then the NAC will actually check, are you still active user? Which groups you belong to, which level of access you want to have, et cetera, et cetera.
All right.
Yeah. Okay. Now, this is the BYOD portion, right? So what we are releasing, and by the way, this is going to be available this summer, early this summer, right? So what we are releasing is BYOD portion. That's what we've looked at right now. We will support Windows, Mac, Android, iOS at the start, and Marvis client will be the vehicle that would actually configure the your-end device and push the cert, push the Wi-Fi profile, etc. Now, with that, we are also releasing full-blown cloud PKI or certificate infrastructure delivered as part of the NIST dashboard. What this means is it's not just about BYOD. You can also use it for your managed devices
via our existing MDM integrations that we currently have. So that means that if you have your managed endpoints via Intune, via Jamf, again, this is what we'll do at the start. You can actually use our cloud PKI to let your clients get their certificates from our PKI while MDM is still managing the client, right? So there is no need to install the Marvis client app. The MDM will do the work for you, and we'll just use our PKI endpoints to do that.
Slava?
Yep.
I have a question. If you're running a Marvis client on one of those OSs, can that Marvis client also be Marvis mini agent?
So we've started talking about the persona of the Marvis client that sends telemetry. That's an option that you will have when you will be able to send telemetry from that Marvis client installed on the device, saying basically, which APs are you hearing in the environment when you're roaming? Why do you actually make these decisions, et cetera. So you will get that level of information optionally. Once we get to minis, then Marvis client is yet another presence point for us. So yes.
Thank you.
Okay. All right. Any questions on the PKI or onboarding? Okay, very good. So again, as I said, this is available this summer. We're getting really close to get this released. Very excited about it. There are lots of companies out there that are they don't have the PKI, or they don't want to keep managing the on-prem PKI anymore. So we want to provide a simple and seamless solution to them. Now, item number 2 I want to talk about is, it's a fancy name of saying this, it's an always-on posture, or continuous authorization, if you will. We've been doing integrations with various MDM providers since the start. So we do integrations with Intune, Jamf, VMware, Workspace ONE, SOTI, et cetera. Now, the way these integrations have done, or have actually allowed us to do posture assessment, right? So you're getting the endpoint health or compliance status from that MDM, and you use that compliance status in your policy. So you say, if Intune tells us that the device is compliant, go and have unrestricted access. If you're not compliant, go into quarantine and have some more restrictions. The challenge was with most of these is MDMs are not very frequent at actually checking with the client themselves, right? So they may check with the client every couple of hours, and within these couple of hours, anything and everything may happen. So in addition to what we do today with MDMs, we're actually doing working on integration with EDR platforms that are that have agents on your devices, and their only purpose is actually to determine if your device is infected, if it has malware, if it has some uncompliant things installed on it. But what they provide to us is really the real-timeness of data. So this is the first time when we add an option to ingest data into our access assurance live from these providers. Right, so it's not like we have to wait for something to happen, or call periodically, or wait for the authentication to repeat. Anytime the client is, for example, detected with a malware, there is a notification sent to us from one of these EDR providers. We will start with CrowdStrike and SentinelOne. So they will send us live notification. We will be able to immediately change the policy on the client. Right, so that's why we call it like an always-on posture enforcement. Now let's look at the demo. So what we'll look at is, it's a simple scenario. We will first look at the additional. We're just looking at SentinelOne as an example here. So we have Sentinel-1 account linked in our dashboard. So again, it's a one-time process where you link your Mist dashboard with your EDR providers who provide an URL and an API token. Easy as that. The second point is you need to create a list of policies. So again, here we're just creating 3 simple policies. We are looking at infected clients that need to drop into quarantine VLAN and get quarantine role or policy. Healthy clients will get full access into employee network and get employee role. And unknown, maybe they don't have an agent, we will still put them on a quarantine network. Now, we'll look at one client example. So we'll pull some NAC live data coming from one client that's connected, and I'll show you like what is the problem we're trying to solve here. So look at the initial connection of that client. So at 2:36 here, you see there was an event that's saying this client was allowed to connect to the network at 2:36. Right, it went through all of these authorization processes. So we did the EPTLS authentication. We then did a lookup in Sentinel-1. It was actually deemed healthy at that point. Right, the client was okay. So we let them in, and the client got full access, no restrictions. Now, let's look at what happened to this client just a couple of seconds later. We'll move to the Sentinel-1 dashboard, or the video will move to Sentinel-1 dashboard. What we did. So now what we see is actually we've detected a malware for this client 10 seconds later after it joined the network. Right? So in the normal world, you would have waited for another couple of hours before you would put them into quarantine. But in this case, Sentinel-1 says, "Oh, actually, I'm going to send a notification webhook back to NAC, and this will trigger an action on our side." Right? So we're sending the webhook, and then once we move back to the Mist dashboard, what you'll see is actually there is a dynamic update event saying, "Hey, now this client is infected. Now rerun the policy." So it will actually do the change of authorization, whether it's a wireless or wired client, doesn't really matter. It will always bounce the connection, rerun the policy, and at that point, with the new status, it will give the more restricted access to the client. Now, the beauty of this is you don't really have to do much in order to configure this, right? So you just link your EDR provider into the Mist dashboard, you create some policies, now boom, you have your posture assessment happening in real time. So that's the beauty of it. I'm going to pause and see your question.
Can you define can you be specific about what triggers that? Because I know like some EDR solutions will trigger alerts and like a posture state change when it's just, encryption has been temporarily disabled because an application is loading or something is running. Can you be prescriptive with that?
Right. So you can be. So again, depending on the EDR provider, they all have their own metrics, so to speak. So in case of Sentinel-1, it's the client is either infected or it's not infected. And the infected status is defined on Sentinel-1. All these policies are happening there, right? So you're defining what it means to be infected. We're just getting the status, yes or no. We say, with some others, so let's say CrowdStrike, they would actually give you the risk factor. They will give you like low, medium, high, etc. So you will be able to specify in your access assurance policies, like, okay, if it's a low risk, maybe let it stay connected with less restrictions. If it's high risk, drop it in some dead VLAN. I'm going to deal with this later. But the compliance logic happens in the source of truth, which for the client, which is your EDR, really. The NAC is only getting that information back from the EDR saying this client is infected. Let us also isolate that device on the network side.
Okay. Can I have one more follow-up question with that? Because so many of the EDR vendors have their own like auto quarantine at the software level where they can do things on the interface or they can modify the firewall. What was the gap that you saw where we needed to be doing this back on the network again?
So again, it's if you look at at the existing EDRs, and most of the time they have a very like yes or no kind of triggers. So you either block all access on the agent itself, or you allow everything, and then you start enforcing some restrictions. But there is no granularity in terms of what policy you can assign in these scenarios. In many EDRs that we've seen. Now, what you really want is to actually move that client and isolate it from the rest of the, let's say, unrestricted network, so you can actually prohibit the east-west traffic. Right. So if you move it to quarantine and only allow outbound connection to the internet, then your east-west is safe in that scenario. Does that make sense? Okay. So Sentinel-1 again, CrowdStrike as well. Let's talk about the third thing. The third item of the day is profiling or fingerprinting, depending on how you want to name it. So, and for the most part, really, we've been very successful doing all of our wireless profiling by leveraging the multi PSK solution, where your key is really the identity for the IoT, and then you assign a policy based on which keys the client is using. But the challenge was always, so this was coming from customers saying, "Hey, I have a bunch of wired devices that are IoT. Obviously, don't even dream about doing that 1X on them. So you're only left with maps. So what else do you do?" So this is really an attempt for us to simplify the onboarding of the IoT devices. Mainly this will be a wired use case, but you can always extend this to wireless as well. So what you will see now is you will see a new capability of doing profiling as part of your access control policy. So in your auth policy rules, you will be able to match on device type or device family. So it's an AP, an IoT device, gaming console, blah, 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 or device manufacturer, or OS, or model. You want to be that granular. I hope you don't. And then you can mix and match all these four buckets as much as you want. So in this scenario, we'll look at just 5 policies, just do some basic segmentation. So we have our cameras, we have our IP phones, we have our printers. So we are matching on the device type, which is, say, a camera, and maybe we only want to drop our access cameras to specific VLAN. And again, the policy config is super simple. Everything is available, again, in one place. But what's important is the onboarding flow. So when it comes to profiling, and when it comes to profiling in NAC, especially on the wired side, the challenge is, okay, so how do I profile the device before it's on the network? I need that device to send some traffic, so I can look at it and tell you what it is. So what we are doing is really creating that last policy rule here that says, okay, if you don't match any of the policy rules, right, you will drop into that catch-all policy at the bottom. We will move you to some staging network or any network with very restricted access, fairly dead-end VLAN if you want, as long as the device can send some packets out. Once the device is dropped into that staging network, we'll do the fingerprinting in the cloud. We'll then, once we determine what the device is, we'll bounce the port, we'll reapply the policy, and then move that client to the correct VLAN. So we'll look at the example of one access camera that I had in that policy before, and we'll look at the flow. So initially, when the client connects, you'll see that at that point, the switch is the map, and the only thing we see is really the MAC address of the client, and that doesn't give us much except the Mac UI. Now, so you could see OS is empty, model, device type, everything is unknown at that point. Now you'll see that there is a fingerprint change event that actually, there is a microservice in the cloud that actually looks at the packets that are sent by the client, and streamed to the cloud. Once we know what that device is, in this case, it's a camera. There's a model of it. It assigns a family to that device. We will then issue a COA, or in this case, since it's a wired device, we are always doing a port bounce to make sure the client gets the AP from the new VLAN. And at that point, we are matching the new authentication policy rule, which is designed for our cameras. So that process is fully automated. Again, the beauty of this is you don't really need to configure anything else on the switch side or anywhere else. The only thing you need to do is to configure the policy. All the COA port bounce thing is all automated and done by us, right? So something that you'd probably spend quite a bit of time with other NAC products that's simplified, and now it will be available in Access Assurance. In fact, it is now in early access. I forgot to say. Now we'll talk about, and please interrupt if there are questions in between, but I will talk about some specifics on, actually, the slide is not turning. Now it does. Okay. So some specifics, right, on how we are doing and what we are doing behind the scenes. So as I said, this is a fingerprinting or profiling service that runs in our cloud. It gets data from multiple sources. So it gets network side metadata that comes from our switches, APs, or even third-party devices that are using our NAC. It gets data from Marvis client if it's installed on the device, or any third parties that we integrate directly. So all these MDM, EDR integrations I've spoken about, we actually get fingerprinting info about the endpoints as well. So all of that gets sent to the fingerprinting service, kind of does its magic. It has its own logic on how to prioritize certain information over other. It produces the final fingerprint that it actually sends down to our NAC pod, so all the policy can actually be applied, and the proper segmentation will be done. Now, what it also does is it continuously reevaluates the fingerprint, right? So some of the things that you see in some products is, the fingerprint is only detected once and then it stays forever. So we are actually reevaluating it based on the data that keeps coming to that profiling service. And here, what you see is it's completely passive right now. There is no requirement to put any span ports, any taps or sensors or probes or anything like that. We get the information from the network inline. Right? So that's the important point.
Hey,
now,
Slava.
Yep, please.
If it's passive, is that assuming it missed infrastructure, whether it's switches or APs?
Not only. So today, so for third party, we also get information in radius accounting. So like there's device sensors in pretty much every solution out there. So they would send you the metadata that we need, and we can parse that as well.
But I assume it's going to be more accurate if it's your infrastructure and you've got the full data flow.
It will be, yeah. So, and again, this is what we release right now with the passive info collection. I'm sure next year on MFB you'll see this slide change a little bit.
Slava.
Oh yeah.
Quick question. Can you put any sort of custom fingerprints in? So if you've got an unusual device that you know how to identify it, how can I tell MITS this is what this sensor looks like or something like that?
Okay. So right now, you cannot feed the fingerprint back to us. But what you can do, and again, before this profile, I should have mentioned, the way we've been doing, and many customers integrate with our NAC endpoints through API interface. So, if a customer has CMDB with all the data and they know what their devices are and where they are and what they are, they can actually push this data to us through API And we have very, very, very large customers doing that at high scale. I mean, like millions of endpoints. Now, with the profiling, this is an automated way for us to actually do this for you. If you want to tag something specifically, you have an unusual device, you can actually create an endpoint, like there's a NAC endpoints page where you can tag the client with certain labels. So you can say this is a camera in building 1, floor 2, XYZ, something like that. Use these labels in the policies. So that's something you can do today. We are looking at providing like a feedback loop for the customer to actually say, oh, this profile that you've done automatically, I want this improved because this and that. But we're not there right now. Okay.
Are you seeing an uptick in profiling, say headless IoT devices, sensors? What kind of momentum are you seeing there?
So the primary, as I said in the beginning, right, the primary use case is really wired IoT. So like take enterprise, there's all sorts of things like starting from IP phones and printers to all sorts of OT sensors or controllers, et cetera, et cetera. So these need to be profiled and they need to be dropped into a particular segment. On the wireless side, again, because prior to that, we've been doing the multi-PSK type IoT deployment where, a PSK is actually used by a certain device type. So you say, this is a PSK for my HVAC, this is a PSK for my cameras. And at that point, this is very deterministic. It's kind of implicit trust. So I'm, again, seeing more profiling on the wired side versus wireless. It doesn't mean that you can't combine it.
Okay.
Slava, I have a question. I'm just trying to think about this from a higher ed point of view, because there's a lot of BYOD devices. I could potentially see a ton of policies being created, and tying back to that Marvis client that gets installed. One of the questions that was brought online from Anders was eduroam. So how are you integrating and making that more mainstream with eduroam SSIDs? Like, can we push that certificate through the Marvis client? Is that just a Marvis?
So let me rewind to the beginning. So if you look at this, right? So the Marvis client is what actually allows you to onboard your devices to eduroam. So think of a student coming into campus. They're there for the first time. All they do is they log into the portal with your university credentials, right? It will let them provision their device by just downloading the Marvis client app, and it will what it is doing here at this step. It's actually provisioning a certificate for that user, and it's provisioning the Wi-Fi profile, right?
Okay.
Now, the certificate that you provision here, it has the user identity. So you can actually create a policy in Access Assure and say, oh, hey, this user is part of the student group. I'm going to drop it in the student VLAN. So your policies will be very, very simple. Your policies will say, oh, if it's a student, go here. If you're a staff, go there. If you're somebody special, do something else. But the Marvis client will allow your students to onboard. This is the BYOD portion. The PKI solution that I've shown on the next slide for the MDM integrations, this will help you for your managed devices. Like if you have any, like sometimes staff devices are managed in higher ed. And in this scenario, you can actually differentiate between the two by just looking at the certificate and how the certificate looks. So we provide that capability and granularity today. But actually, our higher ed customers are using that extensively today.
So when you say certificate, you're talking about a MIST certificate.
Yeah. It's a MIST issued certificate, but that cert is issued to your end user device.
Okay.
Yeah.
The left of this is MIST issued, correct?
MIST.
It is MIST issued, yeah.
The left side is.
The left side and the right side is as well. It's MIST issued. It's the cloud PKI that we host,
right? That cloud PKI will be your PKI for your organization, right? It's not shared with anybody else, but it's going to be issuing certificates for everything on the left-hand side if you're using the app to onboard. And if you have MDM integration done, then it will be issuing certificates for your MDM managed clients. So the difference is for MDM clients, you don't need to install a Marvis client app because the MDM is actually the facilitator. The MDM will put the profile and the cloud PKI and the Mist cloud PKI will sign that cert.
Okay, so it's designed to replace Intune's cloud PKI.
Yes.
Oh, but it would only apply to the ones that you onboarded through that portal, through the Mist infrastructure, et cetera, et cetera.
Correct.
Okay.
Slava, maybe just to interrupt. I think the point is, so today, first, to support certificates within Access Assurance, we're using, third-party CA, bring your own CA, right? What we're saying is with the Mist Cloud PKI, we can operate in both a sort of a provision on devices using the Marvis client, or through a managed type of workflow using a SCEP type integration.
Yeah, I'm just trying to figure out where it would make sense in a managed device scenario to use this platform instead of something that we already have.
Yep.
Right, more
it's an option.
In Root CA or Intune, right?
Yeah, it's an option, and there are still a lot of customers who don't have any PKI today, or they're planning to migrate from the legacy Windows CS services. That's when this will be an option.
Awesome, Slava. Are you good?
I'm good.
All right.
Actually, one last thing, because we've digressed and we've went back to Marvis client. So let me go back to the profiling part, because one last thing before we finish. So the reevaluation fingerprint, where this comes handy is actually it allows us to actually do max spoof detection. Right? So when we think about the typical scenarios, especially with auditing, or say you had a printer connected or you had a camera connected, somebody comes in, splits the MAC of that printer, disconnects the printer, connects the Linux device, and starts some sort of attack. So what will happen here is our fingerprint reevaluation will come in handy first, because it's going to do the enforcement. It will say, oh, hey, yeah, you have the same Mac, but you've been a printer or you've been a camera, and now you're a Linux laptop. That's not good. Let us port bounce. We will rerun the policy. You will probably end up in some staging or quarantine VLAN anyway, but that enforcement is immediate. But what we will do is we will also generate a client max spoofing alert saying, hey, this is happening. You may want to look into this because the same Mac was seen as two completely different devices. And we are being really careful here. Basically, just any dramatic changes. So obviously, if you've changed from Windows 10 to 11, that's not a Mac spoofing. But if you've changed from a printer to a laptop, that's a cause of concern.
Hey, Slava,
Right.
on that, are you tagging that device then with hey, this has been Mac spoofed, so that it can just be blocked until someone goes in and manually reevaluates?
So potentially, and kind of auto action for Marvis, where you would be able to say, hey, I want this to be automatically blocked until I say otherwise. Today, it's reevaluating the policy, and if you don't match the previous condition, you'll likely end up in the default dead-end VLAN.
Awesome. Thank you, Slava. So let me close out just to level set on NAC. Our history in our industry says NAC and happy customers don't belong in the same sentence, right? That's been our history, where this product in general, the category has been tainted with very heavy on-prem systems. We have the happiest customers in the world on NAC. If you don't believe that, you have to try Access Assurance. Sort of proof in the pudding. The largest customer we are deploying right now has 3 million endpoints deploying on our cloud NAC, right? We have actually deployed NAC now. These NAC POPs for a cloud-driven NAC system are deployed around the world. So if an employee from a US-based company goes to India or China, wherever else, they're connecting to the closest NAC POP. All this kind of stuff, completely cloud native. Being able to enable NAC to be easy and simple to be deployed. We've achieved. I'm really proud of the work that has been done on this thing. So if you're new to Juniper Mist and new to Access Assurance, you got to try this to believe this. So, Sam.
Any sort of survivability features with Mist Edge, doing caching and things along those lines?
Oh, yes.
Yeah, we didn't talk about that. We should.
Actually, we did, Sam. Last MMD, we showed that. So we released site survivability late last year. So the way this is done is you have a local site edge that's under normal conditions does nothing but just caching, right? So your clients are still authenticated through the NAC cloud. All the heavy lifting is done in the cloud. Mist Edge just learns the cache of all of the clients we have seen in that site for the period that you specify. So, up to say a month. So if we have seen that client on that site in the last month, and then you suddenly lose all of your internet connectivity, so you cannot talk to any of the NAC pods, APs and switches will automatically fail over to that local Mist Edge, right? And at that point, Mist Edge will start saying, oh, okay, I know the last policy for that client. I know that's the last policy for that client. So they will keep authenticating for as long as you want. So this is designed to survive even full power outages. If the whole building goes down, comes back, and only Mist Edge and APs are available. So yes.